Thanks, guys. Yes, good afternoon, everything, and I'm really sorry I can't be there for you, with you guys in person. But yeah, thanks for coming to this talk around serverless in production, some of my experiences with running AWS Lambda in production. So just very quickly, my name is Yan Shui. I'm a principal engineer at a company called Zone, and as of July this year, I'm also one of the AWS community heroes that focuses around the serverless space. So the Zone is a sports streaming platform. We are like Netflix in that we have a monthly subscription model, and that we are also streaming live sporting events as well as sports events on demand. And we have offices in London, Katowice in Poland, Leeds, as well as in Amsterdam. So we have over 40 different sports around the world and over 200 different leagues. And recently, we also started streaming Serie A and Serie B in Italy, as well as boxing in the US. And we are available in 7 countries and over 30 different platforms. And at peak, we have around 1 million concurrent viewers on our platform, which does bring us these interesting technical challenges. And in the backend, we use a combination of both containers with Amazon ECS, as well as servers with AWS Lambda. Because of some of the current constraints around how quickly Lambda is able to scale up, so for our critical path where someone logs in to start watching a match, we can't use the servers for that. We have to use containers where we have a bit more control in terms of pre-scaling the size of the cluster. But everywhere else, we use Lambda, we use Lambda a lot with step functions, we implement various different workflows, as well as all kinds of different real-time stream processing, as well as the integration with third parties via PopSub. And if you want to find out a bit more about the Zone, what we're doing as a team, you can also follow us on Twitter or visit engineering.thezone.com to find out what we're doing as well. And before I started the Zone, I was working for a social network called Yabbo, where we were trying to build a social network that's a mix of Instagram, Twitter, and Facebook. And it was there that I really learned a lot about how to operate with a serverless architecture in production. Many were lessons that I'll share with you today. So when I joined Yabbo, and this was back in April 2016, we had a pretty simple architecture, at least from the very high level, where we had a couple of monolithic systems running on EC2. We were using our AMQP to do a lot of PubSub and MongoDB as well. Like many monolithic systems, it's very simple on paper, but as soon as you start to peel away the covers, you find all kinds of complexities and interdependencies. Being an early age social network, we didn't have that many users, but we did able to attract a few social influencers from other platforms, and Emily was one of our top users at a time when the whole platform had about 800,000 people. She had about 50,000 followers at peak. And like many of the social influencers, she would run a campaign on our platform whereby she would say, hey guys, follow this post, and I will announce the lucky winner for this beautiful designer handbag at 10 o'clock. So, all day long, we have pretty baseline traffic. There's not a lot of traffic, but then almost exactly 10 o'clock, a lot of people log in to see whether or not they were able to win Emily's designer handbag. And this kind of spike happens always throughout the day as different influencers will run a campaign on our platform. Which means we have very spiky and unpredictable traffic. Which means in terms of our EC2 cluster, we have to gear up a lot earlier than we like. We have to run our cluster at a much lower utilization than we would like as well. Because how long it takes to be ready, typically we see instance being taking about 10 to 15 minutes before it's ready and able to start serving requests behind the load balancer. So whereas most people would probably scale the cluster at around 70% CPU utilization, we will probably be scaling at around 40%. Just so that we have enough buffer headroom, enough headroom in order to view those intraday spikes in traffic. And when you put the two things together, it means that we're spending a lot of money on our EC2 for things that we're not actually using. By my estimate, we were probably getting about 5% of the CPU cycles that we were actually paying AWS for, which is obviously not great. And to make matters even worse, at the time, deployment took about 30 minutes and required a whole system to be taken down and then back up. And there was no maintenance of any kind, so that when we were doing a production deployment for our service backend, the whole app would just freeze. Well, it doesn't matter what you were trying to do, the whole thing would just freeze, which is clearly not good enough by today's standard. And one of my favorite speakers, Dan North, once said that the lead time to someone people say thank you is the only reputational metric that matters. And it's a message that has resonated with me and has really stuck with me ever since. But as engineers, to get the thank you from someone for a job well done, we have to first deliver something. And it doesn't matter how much code we have written, unless our software is running in production, it doesn't mean anything to our users. As far as the users are concerned, we haven't done anything at all unless our software is running in production reliably. So knowing that when I joined Yelp, what we have was clearly not good enough. So I sat down with the team to decide what would good look like for us as a team. And we decided on to decide of the direction that we want to move towards. And so we came up with a list of criteria for what we want deployments. We want them to be small, to be fast, have no downtime, and we don't want to be doing lockstep deployment with the current application because of the sheer amount of coordination and stress involved. We want our features to be independently deployable and loosely coupled to events and messages. And we also want to minimize the amount of cost that we spend on unused AWS resources, as well as minimizing the amount of effort that we as engineers would put into managing and looking after our infrastructure. As far as I'm concerned, the infrastructure should just work. It should work for me, not the other way around. And we inherited lots of technical mess as well, not technical debt. And whilst we try to address those technical mess, we also don't want to take 6 months out and not deliver anything. If anything, we actually want to deliver to our customers a lot faster and more frequently than we've ever done before. And if you fast forward just a few months, we actually arrive at an event-driven architecture that's both service-oriented and also driven by Lambda. Lambda is a centerpiece that glues all these things together. At that time, we had about 170 Lambda functions running in production, doing all kinds of different workloads, from doing BI pipelines to APIs to real-time event streaming, all kinds of different things. And we were paying for Lambda maybe 5% what we were paying for EC2 for comparable amount of compute. But more importantly for me, we went from a world whereby we were doing deployment to production maybe 4 to 6 times a month. Again, because every time we do a deployment is a 30-minute downtime, to easily doing 80 or 100 deployments to production a month with the same team. We didn't have to hire a whole army of developers to go faster. We found tools that allow developers to be more productive and to be able to move faster with the same team. But between deciding that Lambda is a good fit for the direction that we want to move towards, to actually having the first function running in production, we had to answer a whole bunch of questions to know that we can actually operate this serverless architecture reliably in production. And that includes how we're going to do continuous deployments. What about testing all these cloud-hosted functions? And what about logging, alerting, and monitoring, and so on? Ultimately, Lambda is still just a tool. It's a very good tool, and it will probably change the way that we build and run software in the future. But then, and oftentimes you also find that as the tools that you use to build software changes over time, some of the practices and patterns that has emerged in previous paradigms, they have to be adapted, or they sometimes have to be forsaken altogether. But then the underlying principles that underpins those patterns and practices, they still very much apply. Principles such as single responsibility, high cohesion, loose coupling, and so on and so forth. So as our architecture expanded to include more and more functions, many of which have interdependencies, we also had to answer a whole bunch of more questions around how do we do distributed tracing, and what about config management and security. So before we go into those questions and how we answer those questions, I want to just quickly share with you a few things that we were able to build very, very quickly with Lambda. So when I joined Double, at the time we already had a search feature in the app, but it was built on top of using regex queries against MongoDB, which, as you can imagine, just didn't scale well at all. we were struggling with performance even at the point when we had about 100 or 200,000 users. And as a social network, we had aspiration to become a massive social network with millions and hundreds of millions of users. So that level of performance is clearly not good enough. So to fix that problem, we started by making sure that our legacy monolithic system will publish events into Kinesis whenever there's a system state change. So for example, a new user signed up, a user changed their username, they have followed someone, they like someone's post, and so on. All of those becomes events that goes into Kinesis so that we can use the Lambda function to subscribe to those events. And this particular feature for users for search, our Lambda function will listen to events that correlate to user having been created, and then use that to update a user document in Amazon's hosted cloud search, which we can then build an API in front of it using API Gateway and Lambda to create a search API that allows you to easily and efficiently search users by first name, last name, as well as username. At the time, we also didn't have a BI pipeline to speak of, so we also went about building it from scratch. But again, having another Lambda function consuming events, all these events are correlated to systems state changes, and then in this case, we will stream all the events into Google BigQuery, which is a very scalable platform, analytics platform for analyzing data, even exabyte-sized data, and still get back answers within a few seconds. So this whole pipeline took several iterations, but the first iteration took just one developer 2 days from the initial discussion to having something actually running in production. So at the time, our BI guy who just joined us from Sky came to the team afterwards and said that, Jesus Christ, guys, nothing ever got done this fast at Sky, which is of course no offense to Sky, but it all goes back to the point that I was trying to make earlier, that the lead time to someone being say thank you for a good job is the most important thing that we should strive for. And as we became more comfortable and confident in writing Lambda functions, testing them, and also running them in production, we started to go back and tackle some of the more core features in the app. So like Twitter, we had a timeline feature, except the old implementation was so confident, it just didn't work. And there was a detailed UX spec, and lots of tests were being written for it, but it was planning to fail most of those tests. So again, at this point, a new CTO has come in, and pretty much fired half the company, and most of the engineers that was involved the previous implementation, and a lot of problems that we had. And so me and a few other guys came in. We didn't have anyone to talk to about why certain decision was made. So we went back to the drawing board and talked to the product team to understand what their vision for this feature is. And then we went about building it from scratch, but again, using events. But in the case like Twitter, whenever you create a new post, that is an event that goes into Kinesis, which you can then handle with Lambda functions. In the case of me creating a new post, we will have a function that takes your post and tries to distribute it to your followers' feed. And in this case, this function will look at your followers and then batch them into groups of, say, 1,000. And for each batch, publish a message into SNS, which triggers another Lambda function. And the reason why we proxy through SNS here is because between SNS and Lambda, you get 2 retries out of the box, and as well as that letting you support. And in this particular case, the expensive work here is figuring out who your followers are. Like every other social network, you have, say, 90% of your users with less than 100 followers, but then there's going to be 10% or maybe less that are your edge cases that can have tens of thousands of followers, or in some cases, millions of followers. So you really want to avoid doing those, repeating that expensive step of trying to fetch a million followers for a popular user. Which is why that retry is done at a batch level between SNS and the add to feed Kinesis function, which takes your post and adds to your followers feed, which is stored as a sorted step in Redis. And once we have data in Redis, we can then build an API in front of it using API Gateway and Lambda again. In this case, as part of our usual migration strategy from old systems to new services, we will also update the legacy endpoints to proxy the request through the new service instead, so that as a backend team, we're able to roll out changes and improvements without having to wait for the client apps to catch up. When the client teams are ready, they can then move to use the new services directly as opposed to going through the legacy APIs. And like other social networks, we also have features for just you people that you may want to follow. Unfortunately, our implementation was also suboptimal. It was returning the first 30 people in the database by account creation time, which is clearly not good enough. So we also went about fixing it by first creating a cron job that would trigger a Lambda function. And remember that we are streaming all state changes into Google BigQuery so that we can run a query against Google BigQuery and find out who the trending people are on our platform based on how many people that follow them in the last 24 hours or how many people have liked their post in the last 24 hours, and then save that trending user list into DynamoDB and then create an API in front of it using API Gateway and Lambda so that we're able to very quickly create a trending API that allows you to query who are the people that are currently trending on the platform. And whenever you follow or unfollow someone, those relationship changes are also captured as events so that we can use Lambda function to react to those events and update a social graph that is stored in GrapheneDB, which is a hosted version of Neo4j graph database that allows us to then create an API that queries the social graph and makes suggestions for you based on your second or third degree connection. So those are people that are followed by the people that you follow and so on. And again, as part of migration, we update the legacy and the recommendation endpoint to then talk with these two new APIs, manage the dots together, do some randomization, and then return a more meaningful set of recommendations to our customers. So those are just some of the things that we're able to implement with Lambda very, very quickly and really accelerate our product feature delivery. And for the rest of the talk, I'm going to focus on some of the things that you should think about before you actually go into production with Lambda. One of the most important lessons I will impress on you is that don't try to create your own component framework. It's exactly opposite it's exactly the kind of undifferentiated heavy lifting that we should all move away from, and we'll try to move away from with Lambda. The Serverless framework is the most popular framework out there, and it's the one that I've been using for several years now. But then there's also Amazon's SAM framework, as well as several other ones like Apex, Cloudia, Zappa, Sparta, and so on. The point is that as symptomatic of anything that's new and exciting and hyped up, there's going to be a new framework for serverless pretty much every single week. And the way you should, rather than getting distracted by all these new frameworks, you should try a few of them and pick the one that works best for your team and your workflows, and then just mandate it on the team so that between different projects, as I move between different projects, I don't have to learn how to deploy my code again. I can just focus my time learning the new domain and new code base. And once you start writing your Lambda functions, you also need to figure out how you're going to test them as well. And as far as testing is concerned, this is still my favorite book, Growing Object-Oriented Software Guided by Tests. And that's also the first place I've seen what we now call the testing pyramid, where you have unit tests that test your code at the object or module level. And nothing's changed with Lambda in this case. And if you've got some business logic and that you want to test it, you can also write a unit test against those modules where you encapsulate your business logic. And then there's also integration tests that test your code against code that you can't change. And since Lambda and other service platforms are ultimately still just a function that is hosted in the cloud that you delegate to the cloud provider to call on your behalf, so there's nothing that really stops you from, say, calling the function yourself by passing in a stub or mocked event and context object. The thing I will impress on you here, I'll stress here is that given that the purpose of integration tests is to test how your code interacts with things that you can't change, so as much as possible, I prefer to test one integration test against the real AWS services that my code depends on, as opposed to mocks and stubs, which are mostly reserved for cases where I need to test for failure conditions that are really hard to simulate otherwise. And once your code has been deployed, you also want to run acceptance tests to make sure that the whole thing actually works as intended end to end. And so up and down this pyramid of testing, and the unit test is going to give you much faster feedback loop, but then the acceptance test is where you actually get a lot of confidence that the whole system works as intended end to end. And one of the key lessons I learned from the book is that we shouldn't mock types we can't change, because we find that test and mock external libraries often need to be complex to get the code into the right state for the functionalities that we exercise. The message in this test is telling us that design is not right, but instead of fixing the problem by improving the code, we have to carry the extra complexity in both the code and the test. And the second risk is that we have to be sure the behavior we stub or mock matches what the external library will actually do. And even if you get it right once, you have to make sure that the tests remain valid when we upgrade libraries. I think the same principles apply in this increasingly service-oriented world that we live in, whereby our code depends on so many external services that we don't control. And ultimately, I think we need to change the way you think about testing when it comes to serverless, because the risk profile is very different. And if you focus all of your testing effort on what goes on inside the function, and you're stubbing or mocking out all of your external dependencies, then you're going to miss out a lot of things that can actually go wrong when your code runs in the intended environment, say in AWS. For me, for example, the number one thing that's likely to go wrong when I first deploy my code and run it for the first time is that my function is not given the correct permissions. And those are sort of things that mocks and stubs never really tell you. And those kind of configuration and permissioning issues, it's just going to explode when you're going to have challenges, maybe thousands of functions running in your AWS environment. And one of my observations is that most of our functions are actually very simple themselves. Most of them just do one simple thing, and the risk of us actually shipping something broken into production has mostly shifted to how our code interacts with external services that we depend on. And since the whole purpose of us writing any code is so that we can ship some working software a little bit, so personally, I have been quite happy to sacrifice some of the speed of my feedback loop in order to gain better confidence that my code actually does what it's supposed to. And ultimately, I find that even if I got very fast feedback loop, if the feedback loop is telling me the wrong things, that doesn't help me to get to the point of shipping working software at the end. And with most services that you depend on, you're going to find that they're actually really easy to use as part of your test, as part of your automated test as well. Another thing I picked up from the book is that it says wherever possible, an acceptance test should exercise the system end to end without directly calling its internal code. An end-to-end test interacts with the system only from the outside through the interface. So going back to the search API example I gave you earlier, to execute the acceptance test for this system, we will create new users by interacting with the legacy system through its public interface, through HTTP, and the same way that our client libraries, our client application could do, and then we'll run a test to verify that within a reasonable amount of time, we are able to then query the search API to find this new user by first name, last name, and username. Another thing we notice is that when we structure our tests this way, our integration tests are invoking our code locally, but talking to the real AWS services. And once our code has been deployed and we're running end-to-end tests, our tests are also interacting with the same code, but in this case, through the event sources that are actually running in AWS. In the case of an API, it will be through API gateway as opposed to calling the code directly. So the only difference between our integration and acceptance test is how our functions are being invoked. So in this case, when we run our test cases, which are typically very high level, like the one here, whereby we say when we hit the get endpoint, we're expecting some response, some HTTP status code, and some message. And in there, we will have one step that's defined as a function, and inside that, we can have a simple toggle by variables to say when it's some value, then we will execute it by invoking the function locally with stub event and context. And when it's used as a acceptance test, then we will actually talk to the deployed HTTP endpoints in API gateway. And now that you've got automated tests running, you also want to make sure that you want to start looking at your CI/CD pipeline. And since the CI/CD pipelines are there to save you time, also from human errors as well, also I would say that you should you try to look at them, integrate them into your system as early as you can, rather than wait for the end of the project. Again, going back to the same book, the guys also talk about how we prefer to have the end-to-end tests exercise both the system and the process by which it is built and deployed. This sounds like a lot of effort, because it is, but it has to be done anyway, repeatedly during the software's lifetime. So this is where one of the annoyances with many CI/CD pipelines is that you've got all these scripts that only live on the Jenkins box. And at some point, you're going to break it, and you don't have source control to tell you who did it, when did it happen, and more importantly, what was there before, so that you can quickly roll back. So as a rule in our team, every project will have a very simple script, and that just provides a string layer on top of what NPM and the Serverless framework gives us already in order to orchestrate our tests, do the deployment, and then run the acceptance at the end of that to make sure the whole thing actually works as intended end to end. And inside that script, all we're doing is run npm install and trigger service deploy. But the interesting thing here is that rather than using the version of the Serverless framework installed on the Jenkins box, for example, we will have every project will have installed a Serverless framework as a dev dependency, and our script will use that instead. And the reason why we did that is because this allows you to mitigate any version conflicts that arises when the framework itself goes through a major version update. So when the Serverless framework went from 0.5 to 1.0, the whole thing changed. The schema, how it works, all changed. So rather than being a place whereby you have some projects on an old version, some projects on a new version, and have to choose which version of the framework on a Jenkins box you need to run, this allows us to mitigate that whole version conflict problem altogether. And since it's just a simple script, it also allows us to run the build steps both locally as well as remotely to make debugging a lot easier. As for continuous delivery versus deployment, we are doing continuous delivery whereby deployment to production was a manual step whereby someone had to click a button on Jenkins. And the reason why we did that was that our client-side tests were not optimized as much as we would like. So by the time the code gets pushed into masters or we are following Keyflow, we will run unit tests, integration tests, deploy to our dev environment, and then run end-to-end tests against the service boundary level, and then promote it to the next environment and so on until you hit the staging environment, whereby usually the QA team wants to do some manual testing using the mobile devices, at least until they were able to move all the test cases into automated tests. And then to deploy to production, again, it's the manual step to click a button. And then the reason why we did that is because, like many startups in London, on Friday afternoons, we also have drinks, so that you really don't want to be in a situation whereby you're mixing deployment to production with Friday afternoon drinks. Well, and once your code is running in production, now you need to think about how you're going to do all the operational side of things in terms of logging and monitoring and so on. And with Lambda, anything you write to standard out from the code gets captured by the Lambda service and shipped to CloudWatch logs asynchronously with some additional data points around UTC timestamp, request ID, and so on. But the problem with CloudWatch log is that even with the new update, they announced a reinvent for CloudWatch with CloudWatch logs inside, it's still very difficult to search. You can't search across multiple log groups. Every Lambda function has a dedicated log group. So what you'll do is that they'll go to the CloudWatch logs console, pick a log group, and say, I'm going to string the logs for my function to another Lambda function whose job is to then forward the logs to some log aggregation service that I actually want to use. So in this case, we are using logs.io right now, and in the past we also used logly. This function really doesn't care. All it's doing is taking logs from CloudWatch logs and putting it into some other service. This approach is very simple and it's quite cheap when you're not running at scale. But as your serverless architecture starts to expand and more things are being added and you have more and more function implications, this can start to become a problem because CloudWatch logs itself is an async event source for Lambda. So if you have lots of functions running and writing things, then CloudWatch logs is going to trigger this log shipping function and overload. And there's a regional limit of, at least by default, 1,000 concurrent executions. And you don't want to be in this situation whereby you start to exceed that regional limit because too many functions are being invoked to ship logs to logs.io, for example. Which is why at scale, a better approach would be to stream your logs from CloudWatch logs to a Kinesis stream first, and then have a Lambda function subscribe to that stream and forward the logs from Kinesis to your log aggregation service instead. And the reason why this is better approach at scale is that you can control the concurrency of the log shipping function using the number of shards in Kinesis. As Kinesis stream with 5 shards will only have 5 concurrent executions at any moment in time, because with Kinesis, every shard gets its own dedicated execution for your log shipping function. That way, I know for sure that even if I've got 1,000 concurrent executions of functions across my entire account, only 5 invocations will be used to ship logs, so that I don't have to worry about having too many functions to shipping logs and then eating up my concurrent execution quota. Another thing to keep in mind is that every time you create a new function, you also create a new log group by default. And you don't want to have a manual process for someone to have to go into the console to stream the logs to your shipping function. So what you can do here is enable CloudTrail on the account. It then allows you to create an event pattern in CloudWatch that targets the create log group API call that Lambda makes on your behalf whenever a new function is created, and choose it and use that to invoke a Lambda function whose job is to then subscribe this log group to your log shipping function. And if you use the serverless framework, you can also create this event source as part of your service or YAML as well, with a few lines of code. Another thing to keep in mind is that with CloudWatch logs, whenever you create a new log group, the default expiration is never expired. Because Amazon doesn't want to lose your logs without you explicitly saying that you want to expire them. This is all well and good, but because if you're shipping your logs to somebody else already, where you're paying for processing and you're paying for storage, why keep your logs still in CloudWatch logs and continue to pay for storage, which I think is about 3 cents per gigabyte per month. So this cost, if you never expire any logs, will continue to grow on a month-by-month basis. So again, you can apply the same pattern we saw earlier. Have another CloudWatch event pattern against the same create log group API call that trigger another Lambda function whose job is then to update this retention policy to say 7 days or maybe 14 days, depending on how long you want to keep the logs backed up in CloudWatch logs. So it's all well and good having all of your logs shipped forwarded to a log aggregation service where you can search across all the functions easily. But then as your system becomes more distributed, so ultimately you're still building microservices using Lambda. In this case, when I create a new post in our platform, that creates an event into Kinesis that triggers a Lambda function, which then talks to some other relationship API, which is also created with API area Lambda, and a whole bunch of other things happen. So between me creating a post and it ends up in my followers feed, a lot of functions has to process the same data. And what happens if you got a bug in your microservices? How do you then try and figure out where the problem was? Because the problem can happen in any number of these functions. And if you try to look for the logs for individual functions, you're going to get so much noise, and it's hard to correlate everything that happens against that particular post. And this is a common problem in the microservices, and the solution there is to use correlation IDs, which is what we also then apply to Lambda. And in this case, since the event itself ultimately goes through Kinesis, goes through API calls, goes through SNS topics, so both synchronous as well as asynchronous event sources for Lambda, we also have to make sure that our correlation IDs is propagated through all these different event sources. And the approach we took was to create HTTP client libraries, basically wrapping around our the HTTP client that we want to use, as well as create wrappers for AWS SDK clients, so that we can then automatically capture and forward correlation IDs as they come in. In the case of, say, API gateway, when an event is, when our function is involved by API gateway, we can inspect invocation events and know that when the correlation IDs are forwarded to HTTP endpoint, we will include them in the HTTP header so that we know where to extract them using a middleware that can be easily applied to all of our functions. That it also knows that when the invocation event is SNS, then we can extract correlation IDs in the message attributes. And because we are using AWS wrappers to talk to our AWS services, it also means that the function that is publishing messages to SNS will automatically take those captured correlation IDs and include them in message attributes so that the function on the other end knows how to extract them out of those. And we also use Amazon's X-ray service for performance tracing across our many functions. With X-ray, especially if you've taken the time to instrument your code, then you can get a very fine breakdown in terms of how much time is spent at various different steps inside your function. And it also supports API gateway now as well, so that when I have one function talking to another API function, and you can also get a breakdown into what happens inside the second function as part of my trace. And with X-ray, you also get this service map view to see at a high level what are different things that your function talks to, as well as the average latency of those functions. One of the problems with X-ray is that it doesn't span over async event sources. So whenever my function talks to SNS or talks to Kinesis, I'll lose the trace. So the processing that happens after SNS, after Kinesis. There are other vendors now in this particular space. One of them is called Epsilon, which has got a very interesting tool that also supports async event sources as well. So that's all well and good, having logs and being able to do this tracing. We shouldn't forget about the monitoring as well. And one of the challenges in this space is that a lot of the tools that we currently have that relies on you being able to install some monitoring agent or daemon on the server. But with Lambda, you lose access to do that. You can't access the OS anymore. You can't install those monitoring daemons. So you have to rely more on the information you get out of CloudWatch, which, to be fair, does give you a fair amount of information already. And many of the existing monitoring services also has added support for Lambda, including your Datadog and Wavefront and SignalFX and so on and so forth. And there's also vendors that are now specialized in the service monitoring space, IOPI being one of them, and they do something slightly different in that they give you SDK wrapper that can be used to wrap your code so that they can intercept invocations and when your function finishes, and they can then report metrics to their own backend system. They include the data points that are not reported by CloudWatch, things like your memory usage and CPU usage and so on. I think it's a very interesting approach, but one of the problems with this approach with Lambda is that with Lambda, everything you want to do has to be done as part of your function invocation. In this case, once I've done all my business logic, if IOPI wants to send metrics to their own backend systems, that has to be done as part of my function's invocation, which means that now my function is going to take longer to run, and if you're using API gateway, then API gateway has to wait longer for my function to respond. And therefore, my user also have to wait longer for a response from my backend systems as well. Even though you might say that's only 10, 20 milliseconds on average, is not much. But with microservices, it's very common for a single user action to involve multiple API calls, and those 10, 20 milliseconds per invocation can very, very quickly start to add up. And Amazon found a few years back that every 100 milliseconds of user-facing latency you add can cost you as much as 1% in your sales revenue. So those additional tens of milliseconds you spend in sending metrics and doing other stuff after your business logic has run can start to cost you in terms of revenue as well, which is not good. So with Lambda, you've lost the ability to do background processing other than what the platform provider does for you. So one of the workarounds I've seen in this particular space is that you can run your custom metrics as a specially formatted log message, which is what Datadog supports out of the box, so that when they are processed by your log shipping function, instead of sending them to your out stack, you can pass them as metric and send them to your monitoring system instead. And then once you have all your metrics, of course, do the same thing as you've done before in terms of setting up dashboards, alarms, hooking the alarms with Ops3 and PagerDuty and so on. And the last one I want to talk about is how to, in terms of config management. Nowadays, when you create a new function, you can specify a number of required variables. You can also use the KMS service to encrypt them for you. But the problem I find with using required variables is that because they're baked in and specified at a function level, it's very difficult to share configuration across many functions. And because they're baked in at deployment time, you also ties your ability to do deployment with your access to those production secrets. And for most startups, it's fine, because everyone tends to have access to everything anyway. But I find many enterprises, especially those financial institutions, that they can't accept this because they are required by law to restrict the number of people that can access production secrets, and so that at the same time you don't put blocks in terms of allowing people to do their own deployment. So the approach we ended up going with was to use some kind of config service that all of our functions will talk to. And I looked at console, I looked at SCD, but both of them requires me to run against manage and run servers across multiple AZ and pay for them, even if my functions are not running. So nowadays, nowadays you can use Amazon's SSM parameter store from your Lambda function, but they also introduced a new service this year called the Secrets Manager, which also supports the rotations for your secrets. So in this case, you want to make sure that all of your sensitive data, such as passwords and credentials, are encrypted at rest and in flight, and that you have a role-based access to those configuration values. And in the case of SSM parameter store, as a secrets manager, you may have some admin person or potentially a repo that keeps track of all of your secrets and the configurations in the GitHub, they're encrypted using KMS, that whenever that something changes, it gets pushed and distributed to the SSM parameter store or secrets manager, which then makes sure that they're encrypted by KMS and where you have a role-based access. And when your functions, so that they are encrypted at rest, and when your function starts up, during cold start time, you will request those secrets and configuration for SSM parameter store, and they'll be encrypted in flight because of HTTPS. And you also have role-based access to SSM parameter store and secret managers as well. And in this case, we also have client libraries for our function, whereby during cold start, you fetch the secrets and configurations, but then they'll be cached. And then the next location, we don't have to go to SSM parameter again. And there's caching validation that happens occasionally if the function is end up running regularly for a long time. So all the things I've talked about today and more are also covered by my video course with Manning as well, which you can still get 40% off if you call on the screen. And with that, again, thank you guys very much for your time. And I'm really sorry that I couldn't be there with you in person.
Thank you, Jan, for great talk. And it's time for questions. So while people want to ask some questions, I have the first one. So it seems that using Amazon Lambdas, you have some kind of strong vendor lock, and you mentioned a lot of additional services and additional tools you use from Amazon Stack.
Yes.
Did you count probably what is additional cost you have for these tools, and probably you could save money on them if you run your infrastructure, your own infrastructure?
Yeah, so in terms of cost, when you're using all these AWS services, you are paying a premium because, again, you're delegating all the overhead in terms of managing clusters, all that to AWS. But from my experience, the most expensive resource is not what your AWS bill is the skills that you have in the company. It costs me what, $80,000 pounds a year to hire an engineer with the right expertise to manage a cluster, manage something ourselves, and they are not going to do anywhere near as good a job as what Amazon is able to do for services I can use out of the box. And with AWS services, with Lambda, I can very quickly build products and features and ship features to our customers. So if I have to then run everything ourselves, and that's going to cost me into the market opportunity. That's going to take much longer for feature development and so on. So for me, those are much more expensive costs compared to whatever I pay AWS for their services.
Okay, cool. And one more question is, as far as I remember, Amazon provides a huge amount of Lambda minutes for free. How much do you exceed this limit?
By quite a lot. So you do get about 1 million invocations for free. And what I find, and also what I find with most of my people that I work with, is that your cost is with using serverless is much more around the services that around Lambda, not Lambda itself. So, for example, many people will spend more money on CloudWatch logs than they do for Lambda, because again, every function is writing logs, and you need to be able to process and record those logs and search them so that you can debug things. And that has a higher cost than Lambda itself. An API gateway, for example, is about I think $3.50 per million requests. That's also a lot more expensive than Lambda. So what you find is that most of your cost is not going to be on the Lambda invocation itself, but for all the services that you use with Lambda.
Cool. So questions from the audience.
Yeah, thank you very much for presentation. Question about SSM store, parameter store. So you mentioned that serverless is something that you use on top of the AWS Lambdas. By default, and it's also something that is suggested by serverless as one of their best practices, is to directly use encrypted the parameters, just writing right away into the serverless configuration. Basically, you specify the flag, and that's how the serverless understand that it should decrypt them back from the store. From your practical experience, and probably you can recommend something, is the good way of storing those things? Because what happens then, you have those sensitive parameters, they are stored effectively as environment variables of the Lambda function. So you can just see them and directly in your console. So is it something that you find to be a problem, or is it like a usual thing? So what can you recommend in these terms?
Did you hear a question, or I should repeat it?
Can you repeat it, please? Your speed.
Make a long story short. If I understood you right, so when you configure function, you use some configuration parameters, and how could you encrypt these parameters to make not them available through console, for example?
Right. Okay. So with environment variables, you can encrypt them in console as well. So with KMS, it's a tick box which you can also configure by platform or service framework. What we typically do with sensitive data like credentials and API keys is that they are not encrypted, they're not stored in the environment variable at all. They are only fetched at runtime. One of the problem with having those secrets in environment variables, even if it's encrypted in the console, is that at runtime, they are typically plain text, so that if your function is compromised, then the attacker is able to very quickly scan your environment variables, say process to end, and look for them in the plain text. So what we tend to do is for those sensitive data, we don't put them in the environment variables for the function at all. It's fetched at cold start time and decrypted as we try to retrieve them from either secrets manager or parameter store. Does that make sense?
Yeah, sure. This is what was the question about.
Okay, cool.
Hi.
Yeah.
Thank you for your talk. That was really helpful. I have a question regarding the fact that when you are starting to to migrate like the existing solution to Lambdas, it looks like that the most easy way to do this is to start like moving some internal pieces of your application to the Lambda functions and call them via HTTP, or basically expose an API for those functions. And
sure.
As far as I remember, there was an issue that you weren't able to set up API gateways that is available only within VPC. So it was exposed to the internet, which is like not really secure.
Okay, so it's this question about security and API gateway not being inside VPC.
Basically, yes, or maybe, like, what do you think about it? Like, maybe you think that it's okay to call lambdas directly via SDK. I don't know. Like, what is the best approach?
So I would say in terms of the security with API gateway, yeah, sure you don't have to put it into you can't easily put it inside VPC, which you can do now. It's still be awkward. You have to do it with VPC endpoints. But with API gateway, you have a number of authentication methods, which means that, for example, for internal APIs that are not intended to be called by the public internet, you need to use IAM authentication. So even if you're public facing, in the same way that Lambda itself is public facing, but you can lock it down with IAM so that you don't need to put it inside a secure network just to prevent unauthorized access. And you can do the same thing with API gateway as well.
Okay, thank you.
Okay, any other questions?
Can we go back to the slide with the promo for the book?
Can we go back to the slide with the promo of the book? Yeah.
Yes, okay, there you go.
I have this one already. Cool. Thank you. No more questions? Okay. Thank you very much for joining us.
Thank you.
We really hope you will join us next year in person.
Yes, I hope so. So I was really looking forward to it until just before the whole thing with Ashley.
Thank you. Bye.
Thank you. Hey guys. Bye-bye.